The translator is responsible for translating one language to another language. Whatever the program I'm going to write except machine code are always called source code. Computer understands only machine level language, that is nothing but zeros and ones. Hello to all, a warm welcome to my new session on software concept. I'm Revati, faculty, Department of Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Before going to start my today's session, let me to recall the things what we learned in my previous session. In my previous session, I started with an introduction that is all about software. So what is software? What is the need of software? So what is software here? Here softwares are nothing but the set of instruction or computer program that is given to the computer system to perform specific task. That means what task the computer can able to perform and what are the tasks the computer cannot perform. That is all about software. So what is software here? Software is nothing but the set of program or instruction used to perform certain task or specific task. Then we had discussion regarding the type of software. That is, we are having two type of software. One is application software, another one is system software. So here what is system software? Here system softwares are nothing but the computer program or instruction, and it is used to interact with the application software as well as computer hardware. Then what are the different types of system software we are going to have? That is operating system, translator, along with that utility software. Then we had discussion regarding application software. So what is application software here? The application software is nothing but the computer program, or it is nothing but the set of instruction that is designed based on the user requirement or based on the user need, or it is a set of program that is designed to perform intended task. There are two types of application software. One is general purpose application software, another one specific purpose application software. Along with that, we had discussion regarding computer language. So what is computer language? What is the need of computer language? We know that a computer is an electronic device and it's an dummy machine, because without any instruction, computer will not perform any task. Suppose if I want to get the work done by the computer system, then I want to instruct or I want to give the command to the computer system. And whatever the command I have, that is written by using computer language. Then we had discussion regarding the different kinds of computer language. So computer language is nothing but the programming language. There are two types of programming language, that is low level programming language and high level programming language. Under low level programming language, we are having two types, that is machine level language and assembly level language. Under high level programming language, we have two types. One is general purpose and another one specific purpose high level programming language. Now, in my today's session, I'm going to deal with language translator. That means why I require language translator and what is the need of language translator and what are the different kinds of language translators we are going to have. Along with that, we are going to study assembler, compiler, interpreters, then linker and loader and utility software. Now, instead of wasting much of time here, directly moving on to the topic, that is language translator. Now, consider the situation that I know only English, Hindi and Kannada. Now, if the third person want to communicate with me and that person knows only Tamil and Telugu, then is it possible to understand? No, because I know only Hindi, English and Kannada. But that person knows only Tamil and Telugu. Now, I required one mediator or one person who knows Telugu, Tamilu, along with that Kannada, Hindi and English, because that person is able to translate Tamil or Telugu to Kannada or English or Hindi. Now, what is the job of translator here? The translator is responsible for translating one language to another language. Similarly, if I consider computer understands only machine level language. But if I consider programming language, I'm having high level programming language as well as low level programming language. But computer understands only machine level language, that is nothing but zeros and ones. Now I want to convert all the high level language to machine understandable form, or all the assembly level language to machine understandable form. For that I require translator. So here the translator translates the high level language into low level language. For example, say I have written hi and this is in high level language. Now I want to convert this hi to zeros and ones. To convert this high level language to machine level language, I'm going to have the translator. That means, what is the job of translator? It is just converting one language to another language. And there are three types of translator. Here, computer system supports three types of translator. One is compiler, another one interpreter, and last one assembler. So, dear student, from the examination point of view, what is translator and what are the type of translators are very important. So, what is translator? Here, translators are responsible for translating high level programming language to machine understandable form, that is nothing but machine level language or machine code. And we are having three type of translator: compiler, interpreter and assembler. Before going to know about all these translator, let me to explain what is source code. So what is source code here? It is a program written in a language other than machine code. So whatever the program I'm going to write except machine code are always called source code. So almost all the source codes are written by using high level programming language. So here, what is source code? It is a program which is written by using high level programming language itself called source code. Then what about object code? A code that is produced by the compiler. Dear student, just consider the example that I'm going to write program 1.cpp. Think that this is my C++ program. So this program itself called my source code. source code. Once I compile this program, after that whatever the output I'm going to get, that is called object code. Now what is the object code here? Here object codes are produced by the compiler or assembler and typically sequence of statements or instruction in machine language. So dear student, just remember one thing here, that object codes are always produced by the compiler and it's nothing but a sequence of instruction, and that is in the form of machine language. If it is in the form of machine language, then obviously it is nothing but zeros and ones. So here I want to remember two things. One is source code and one is object code. And both these are different because first what program I'm going to write, that is my source program or source code. After compiling whatever the machine code I'm going to get, that is nothing but object code. Moving further, I'm going to have first translator, that is nothing but an assembler. So what is assembler? What's the need of assembler? So here, to compile assembly level language to machine level language, I required assembler. So it is a translator. What's the job of assembler here? It acts like a translator. That means translating one programming language to another programming language. So assembler is system software. So dear student, remember one thing here, that we are going to use assembly level language. So here all the assembly levels language uses mnemonics. So what is mnemonics here? Here mnemonics are the special symbols or special characters or words. And by using these words, we can able to write assembly level language. And it recognizes the mnemonics used in the assembly level languages and substitutes or replace the required machine code for each instruction. As we know that in an assembly level language, we are going to use mnemonics. Now what I want to do, I want to substitute mnemonics with the machine code. That is the job of the translator. Now the example for assemblers are Turbo Assembler, Masem Assembler, that is Microsoft Macro Assembler, PASM, NASM, etc. So what is assembler? We are going to have the source code. So what's the example for source code here? That is nothing but assembly level language program. That is the input to the assembler. What is the job of the assembler? Here the job of the assembler is to substitute assembly level language to machine instruction or translate assembly level languages into machine instruction. That is the job of the translator. So after substituting or after translating, whatever the output I'm going to get, that is nothing but the machine code or object code. Now what's the input? That is assembly level language that is given to the assembler. Now assembler is responsible for converting assembly level language into object code or nothing but the machine code, and this is the job of the assembler. Now I'm having second type of translator, that is nothing but compiler. In compiler, initially what is my input? That is nothing but the high level program. After compiling, I'm going to get the object code, that is nothing but the machine code. So here the compiler is also the example for system software that is responsible for translating high level language, that is nothing but the source code, into machine level language, that is nothing but machine code or object code. Now it reads the whole program. If I consider compiler as my translator, then what is the job of the compiler here? It's going to translate whole program into machine code. So it reads the whole program and translate the entire program at once into a series of machine instruction or machine level language instruction. And once the program is compiled, the program normally gets saved automatically and can be executed directly. That means once the high level language programs are compiled, after that it is automatically saved in the memory and it is automatically executed, or it is executed directly. And this is the example. So here, what is my source code? That is nothing but the high level language. That means whatever the program which is written by using high level language is called source code. And this is the input and this is given to the compiler. So what is compiler here? That is nothing but the translator, or it is nothing but a mediator. That means the job of the compiler is to collect the input and translate the input into machine understandable form. So what is the input to the compiler? That is nothing but source code. So what is source code here? It's nothing but the high level language. After compiling, what's my output there? That is machine code, or it is nothing but object code. For example, think that I'm going to have hi. So this is my input. Once this is compiled by the compiler, what's my output? This is my output. That is nothing but object code. So what is object code here? That is nothing but zeros and ones, and which is understood by the computer. Then I'm going to have the interpreter. So what is interpreter? In general, what is interpret? Interpret means what? It's nothing but execute or translate one line at a time. That is nothing but interpreting. So here, what is interpreter? An interpreter reads once a statement of a high level language program. That means whatever the source code I'm going to have, in that the interpreter reads one line at a time. After reading one line, it is going to execute or translate that line into machine level language and executes it immediately. So what is interpreter here? It's going to read one line from the source code, translate that line and execute that line immediately. After the execution of that line, now interpreter takes another line from the source program, convert that into machine level language and execute, and this sequence continues. So what is the job of interpreter? It is going to interpret at a time. That means it's going to interpret one line at a time. After the completion of that line, it's going to take another line, translate that line to machine code and execute. This is the way the interpreter is going to work. It continues to read, translate and execute the statement one by one. If I consider interpreter, what is the job of the interpreter? Read, translate and execute. That means it is going to consider first line, read the line, translate the line and execute. After the completion of first line, go to second line. So it is going to read, translate and execute the statement one by another until it reaches the end of the program. Then what is the disadvantage here? It is slow when compared to compiler. If I use compiler, it's going to translate whole high level programming language into machine level language. But if I consider interpreter, it's going to translate, or it's going to read, translate and execute one line at a time. So here the interpreter is slower than the compiler. Now the machine code as produced by the interpreter is not saved, and hence to execute a statement again it has to be interpreted again. So in interpreter I'm going to consider one line at a time. That means I'm going to read that line, translate that line and execute that line. So here I'm going to perform translation only one time for one line. So each time when I translate, the same time I'm going to execute that line. So the machine codes produced by the interpreters are not saved, because if I consider interpreter, what's the job of interpreter? Read the line, translate the line and execute the line. So here whatever the lines are interpreted, that is not saved in the computer memory. And if I want to execute same line once again, then I need to interpret that line once again. So this is the disadvantage of interpreter once again, because I'm not going to store all the results in my computer memory, because once I translate the line, immediately I'm going to get the output. If I want to execute same line once again, what I want to do? I want to interpret that line once again. And example for interpreters are basic, prologue, etc. These are the programming language that is going to use interpreter. Now I'm going to have the comparison between the compiler as well as interpreter. Now what is my first difference here? Compiler takes entire program as input. That means the compiler is going to consider the whole program as its input. And if I take interpreter, it is going to consider single instruction as input or one line as input. Then intermediate object code is generated. That means after the compilation, we are going to get the intermediate object code, that is nothing but the machine code. And if I consider interpreter, I don't get any intermediate object code, and the conditional statements are executed faster. In compiler, we can able to execute control statement more faster. If I consider interpreter, the conditional control statements are executes slower. That means here I am going to consider only one line, and to complete that line it's going to take time, because I am going to execute one line at a time. But if I consider compiler, I am going to execute whole program at a time. And the compiler requires, that is, what's the memory requirement for the compiler? That is more, because compiler occupies more memory space, because we are going to get the intermediate result, that is called object code. And if I consider interpreter, it is going to occupy very less memory space, because it does not generate any object code, and the program need not be compiled every time. That means each time if I want to run your program, then no need to compile that program. If I consider interpreter, each time I need to interpret, because after interpreting, it is not stored in the computer memory. And if I consider compiler, errors are displayed after entire program is checked. That means if I consider compiler and if I compile my program, I'm going to get the errors at the end of my compilation. If I consider interpreter, after interpreting each line, I can able to get the errors, or errors are displayed after every instruction interpreted. Now, if I consider compiler, what's the example? That is C compiler. And if I consider interpreter, the example for interpreter is basic programming language. Then I'm going to have linker and loader. So what is linker? What's the need of linker and why I required loader? So the name itself indicates that it's mainly used to link two programs or two sub-programs. So a source program written in high-level language may contain number of modules. That means by using high-level language, I can able to create my own modules, and it may include n number of modules or segments. Now, to execute all these segments properly, what I want to do? I want to link all those segments together, and that can be done with the help of linker. So, that execution of the program is sequential. In linker, the execution of the linking of the files are sequential. So, what is linker here? It is mainly used to link the files. For example, think that I'm going to have 4 modules in my program. Now, the proper execution of the program, I need to link all these modules or sub-programs together and sequential. And that can be done with the help of linker. This operation is performed by software called as linker. So, the software name itself indicates that it's mainly used to link the files. That means whenever I want to link any two files together, obviously I'm going to use the software called linker. The job of the linker is to link two files or link more than two files together. Now, a linker is example for system software that links. So, what is linking here? Linking is nothing but combining smaller program to form single program. So, what is the job of linker here? It's mainly used to combine smaller program together to form one final or one single program. Then I'm going to have load. So once the executable file is generated, someone will have to load the program into the main memory. Once the linking of the files are over and the executable programs is generated, and now I require some software to load that program into the main memory of the computer. That is done by using loader. Now tell me, what's the job of the loader? The name itself indicates that load the program to the main memory. Once all the files are linked and we are having executable files, now that file is stored in the memory. It may be stored in our secondary memory. Now I want to load that program which is stored in the secondary memory to the main memory. That can be done by using loader. So once an executable program is generated, someone will have to load the program into the main memory of the computer so that it can be executed. This operation is performed by the software called loader. So, as the name itself indicates that load the program to the computer memory. So, what is computer memory here? That is nothing but main memory. So, a loader is system software. This loader is example for system software that loads machine code of a program into system memory. So, what is the job of the loader? Loads the machine code of a program into system memory and prepare these program for execution. So, what is the job of loader? Load the program to the main memory and get ready to execute the program. This is the job of the loader, and these two are example for system software. And the last type of system software is utility software. So the system softwares are categorized into three types. One is language translator, then operating system, and utility software. Now, what is utility software? Here, utility softwares are the software and are those helpful programs that assist the computer by performing helpful function. So here, utility softwares are the computer program or software that performs some helpful functions. That means that assist the computer system to perform some helpful functions like scanning, clearing virus, or backing up the disk. Suppose if I want to protect my computer or laptop from the unauthorized access or malicious activity, then I'm going to use antivirus. If I want to take any backup of my programs or my drives, then I'm going to have backing up disk. So here, utility software is generally called application-oriented ready-made system program. So what is the another name of utility software? So here, utility software is nothing but application-oriented ready-made system program. And we can expect this one for 1 marks. So what is utility software and what is the name of the utility software? So utility softwares are commonly identified as application oriented ready-made system programs, and some of the very important utility softwares are text editor, backup utility, disk defragment, and antivirus software. So what are the example for utility software? So the common example for utility softwares are text editor. You can consider any kind of text editor. Along with that, backup utility, disk defragment, then antivirus. These are the example for utility software. So dear student, in my today's session, we started with translator. So what is translator? Translator is mainly used to translate one programming language to another programming language. Then we had discussion regarding the type of translator, that is compiler, interpreter, assembler. Along with that, we had discussion regarding utility software. Along with that, we had discussion regarding the examples of utility software. Now I'm going to recall what are the topics we discussed in my today's session and in my previous session. In my previous session, I started with computer software. There are two types of computer software, that is application software and system software. So what is software here? That is nothing but set of instruction or nothing but a computer program, and it is classified into application and system software. So here application software is further classified into two types, that is application specific and general purpose. And if I consider system software, it is further classified into four types. Language translator. In language translator, we had discussion regarding what is assembler, what is compiler, and what is interpreter, and how they are going to work. Then we are going to have operating system. Anyway, in my next session, we are going to discuss about operating system, the functions of operating system, and some of the examples for an operating system. Then in my today's class, we discussed what is utility software, what's the need of utility software. Along with that, we had discussion regarding the examples of an utility software. Then we had discussion regarding what is loader and what is linker and what is the use and why we are going to use loaders and linkers. And these four types are the type of system software. So system software is classified into four types: language translator, operating system, utility software, and loader and linker. So dear student, in my next session, I'm going to deal with what is operating system, what are the functionalities are provided by an operating system, and the different types of operating system. So these are the three important topics we are going to discuss in my next session. Until then, keep learning and keep watching. Thank you.